Okay, shall I stand up or sit down?
It's up to you. Stand up.
Okay, stand up.
It's up to you.
Okay, so following on from talking about emissions that cause climate change, one thing that is relevant to the event sector that leads to emissions that cause climate change is use of temporary power systems that run off diesel generators. So I'm going to talk to you about smart power plants. Now I came across smart power plants through organisation Zap Concepts. Now my background is that I've worked on various events, and one of the doing environmental stuff and also being a site manager. And one of the things I've been doing over the last few years, I've been working on a project at Glastonbury Festival where we're looking at the efficiency of power systems on site and doing a lot of scientific monitoring of the power use in conjunction with the University in Bristol, with the University of West of England in Bristol. And I met a chap called Paul Skurink in the Netherlands, who is doing the same thing over there and has worked with a lot of Dutch festivals to reduce the emissions from the festivals, reduce their diesel use, and run the same shows, the same spectacular shows that people want to see, with much less installed generator capacity. So that's the background to it. It's basically in the Netherlands. Zap Concepts is Paul, and over here it's me. I've gone into partnership with Paul to try and bring some of, well, join our two sort of levels of expertise together in the UK. This is a short, if I can make it work, this is a short video of what event organisers and environmental people don't want to see. So watch what's happening on stage with the lighting, and just see what's happening behind the stage at the same time when the lights come on. It's only 30 seconds. Yeah. So, the ZAP in Zap Concepts stands for Zero Air Pollution, which is what we're eventually aiming for. Now that is an example of lots of air pollution. That's actually from an undersized generator. So the generators are behind the stage there, and that's exactly the scenario that event organisers don't want. They've got a generating capacity that's struggling to keep up with the load on the stage. Those generators are in danger of failing, and then the whole show's off. So what tends to happen to compensate for that, production managers, people who run stages, people who run events will overspec their generating capacity, because the main point of having your temporary power is to make sure that you have power all the time for your show. And this has been a historical thing that's happened over years and years, and it's a bit sort of ingrained in the operation of festivals and events. But what we're starting to do now is look at the actual energy use during the show. So on the graph, sorry to have more graphs, there's not many of them. The graph on the left there shows what's called the load profile. So it's the actual energy use, or the actual, it's actually the actual power at specific points in time during the show. So you can see that looking at that load profile, you've probably got 4 days there, and you've got or three days, and you've got 4 times when if this is a stage set, you've got 4 peaks of power, but in between you're using very little power. But you have to size your generators to meet the highest peak on that graph. So you end up with usually at least 2 very large generators running in parallel, so that if one of them fails, the other one still continues to provide power, and they have to be sized to meet the maximum peak. But the maximum peak only exists for a very short amount of time. So that's one part of it. You've got a maximum peak, and then you've got lots of low load trundling on the bottom, which isn't very efficient. But also, when you're sizing the generators, lots of people size those generators to be 2, even 3 times the size of that peak. And if you look at the graph on the right-hand side, what that shows you is it's the efficiency of the generator based on the actual load. So it's based on how much fuel it's using. So in general, the more power you take from a generator, the more diesel it's going to burn. But it's not a straight line. If you're operating at very low efficiency, so your generator is very oversized for the amount of power that you're taking out of it, the amount of fuel per hour or per unit of time that you're using starts to ramp up quite a lot. And so when you get down below about 30%, you're using a lot more fuel than you would do if you were operating at 50% or 70%. Once you get down below about 10%, you're using 2 or 3 times more diesel than you need to provide the same amount of power. So the point of the Smart Power Plan is to work with the event organisers and the suppliers to try and work out a better way of doing this. So it's a very simple process, but one that at the moment the way power is specified is generally you'll have people on site that need power. They tell you what size connections they need, what size sockets they need. That goes to the power provider. They supply that number of sockets and they size the generation to match the number of sockets. But it doesn't necessarily mean you're taking that amount of power. If you've got a 400 amp cable, it doesn't mean you're necessarily taking 400 amps of electrical current through it. It just means that you're using that size plug. So we split down into looking at the different phases of the show. And the first phase, the most important phase really is the preparation. So trying to accurately spec the power that's required. So instead of just having a list of sockets that you need, and all that comes to an event organizer who isn't very experienced in the technical side of power, or it goes directly to the power company because they are technical people, but they only supply what you ask them to supply. Instead of that, we try and meet, or preferably have a face-to-face meeting, but this can all be done by email, telephone. It's just getting the correct information off everybody involved. So speaking to every supplier who's supplying equipment that needs power, speaking to the event organizer and the power company, and making a comprehensive list of all the power requirements, and asking simple questions to people. So if you ask somebody how many kilowatts of power do you need, they might not be able to tell you. They might not have that technical background, but if they don't know, you can ask them, right, what equipment have you got? Give me some examples of the equipment you're running. Take a photograph of it. Take a photograph of the plate on the back that tells you what the electrical rating is. Send it to me. I'll be able to work out roughly how much power you're going to need, and then we can add on additional things later if you need to. But it's just the most important thing, I can't stress enough, is just accurate preparation. The next thing is you take that information and you look with the event organizer, the site manager, at where it's being used on site, and there's a lot of opportunities to amalgamate different users of power. So you can have power zones. You can divide up the site into power zones, and instead of having lots of generators all over the place running single things, with a little bit of tweaking of the site layout, you can have a central generator running much more efficiently, sending out lots of power to lots of people. Because running a generator set at about 70% of its load, of its optimum capacity, is the most efficient way to run. So you can achieve that by putting more load on the generator from different people. And sometimes the site layout means that hasn't happened in the past, because the generator's over here, there's a road, and then the thing you want to power is over there. So you end up with 2 generators because you don't want to put a cable across the road. And you can discuss this with the site manager or with the event organizer, just to try and make little tweaks to the site layout, which shouldn't affect the audience and have minimal effect on the operation of the festival, and just to make these things happen a bit more efficiently. Then then during the build phase of the event, we look at what's actually coming onto site. So making sure that the correct equipment is coming onto site, and and that it's running for the correct amount of time. So obviously another way, a really obvious way to save diesel and therefore save emissions because you're not burning it, is to limit the runtime of the generators. So a lot of the time you'll find a generator's installed, it's switched on, and then it stays on. And if your build period starts 2 weeks before your show, over that period you'll get generators being installed in different areas, and sometimes those generators will be switched on and left on until the show's over. And it's not always necessary. And then maybe we would never say to anyone, oh, we're turning this generator off, you can't have any power. If someone wants power, they'll always get power. But it's knowing in advance when they need it. We even put a little sticker on the machine that says, right, during these hours, power is required. Outside of these hours, nobody needs power, so switch it off. And it's amazing how much fuel you can save and how much emissions you can save just by turning the generator off when it's not needed. And having someone who's responsible for that, because a lot of the time they don't get switched off because nobody's taken responsibility for it. So then during the show itself, we can look at, the other thing I meant to say is when the generating equipment comes on site as well, we take measurements of the on the generator. It tells you what the running hours are, the total running hours. So you take a measurement of the running hours when they come on site and a measurement of the running hours when they leave site, and then you can tell exactly how long that generator's been running for. And during the show, we'll look at the actual use of the equipment. 95% really of specifying power efficiently is the preparation phase that I talked about before. But you can back this up with monitoring on site of the generator. So in this photograph there is a little black box connected to some clamps on those cables coming out of the generator, and that will give you a record minute by minute of how much power was coming out of that generator, and give you a graph similar to the one we saw at the start. And this is something that I've been involved with at Glastonbury, where we've been working with Aggreko, who are the main power provider there, and they actually have wireless telemetry systems on their generators, where we can look in detail at what a generator in a particular area has been doing. So you can see if you did specify it properly, or if it should have been different. So then in the loadout phase, when you're dismantling everything, the same thing really about running hours. A lot of the time, people just forget to switch generators off because it's not anybody's particular responsibility. So it's important to check who needs power in the loadout and who doesn't. And if there's an area where nobody needs power, switch the generator off. If there's an area where people need power, but the generator there is a big set that was running a lot of equipment which is no longer required, you can swap it for a small one. You can install them all at the same time at the start, and one of them just doesn't run at all during the show, and then the big ones get turned off and the little one gets turned on. Again, you'd be surprised how much fuel gets burned just with the engine idling on a big generator that's only providing some lighting and some power tools for people who are dismantling equipment. And another interesting one is when you return all this equipment in the loadout. If you're using temporary diesel generators, you quite often have external diesel tanks so that you can run the generator without having to drive around and refuel it all the time. Now these tanks, you have to fill them. They're usually delivered with the right amount of fuel in, and then you have to top them back up with fuel before you send them back again. Otherwise, you get charged. But not a lot of people know that the regulations for road transport of fuel mean that you shouldn't fill that container more than 90% full. So if you end up filling the containers 100% full, they probably arrived 90% full, and you've just wasted 10% of your diesel. So just simple things to look at. So sort of racing through this. So after the show, what do we do? We've looked at, we've got some monitoring data from those energy loggers. We've also got a record of running hours, which is simply just recorded off the meter on the machine as it comes in to site and as it leaves site, and then we can evaluate those results and turn it into a little report for the event organisers and the power company, and review if everything was specified correctly. And with events that take place every year, they've been running for years and years, quite often, there'll be new things every year, but quite often some things are going to be very similar year on year, and you can look at this year's results and use those to start planning ahead for the following year and make further efficiencies. When you look at it also shows you things, if you use the logging equipment, it also shows you things that even the electricians are going to miss. So, for example, in that, you won't be able to read it, but in that table there, what it's showing is this is a minute by minute, in fact it's a second by second log of power going to a stage, and it's using 200 kilowatts of power in 1 second, and in the next second it uses 720 kilowatts, and then in the next second after that it uses 200 kilowatts again. So, and this has a timestamp on it, so you can go back and look and see what exactly was happening on that stage at that time that caused such a massive power spike. And this is the next sort of stage. Once you've accurately sized your equipment to what you're doing, you can then start to look at the actual users of the power and say, do you need, what was that spike for? If we removed the cause of that spike, would it make any difference to your show? Would anybody notice? And then you can start to reduce energy use overall. So this is something that we've been doing in the Netherlands for at least 3 years now. So here's an example of some results from this is from a festival, Extreme Outdoor Festival in the Netherlands. So since 2012, they've been using smart power plans, and it gives you an idea of the number of generators. Originally, we didn't reduce the number of generators, but reduced the running hours of those generators and reduced the total installed capacity. So the installed capacity is the total size of all of the generators added together. So you could have 10 generators that are all 20 kilowatt generators. That's if you 20 kilowatt generators, that's only 200 kilowatts of installed capacity. If you've got 10 at 500, then that's your installed capacity. So it's not necessarily about the number of boxes you've got; it's about the size of them, what their capacity is. So with Extreme Outdoor, they managed to reduce the installed capacity overall over those 3-4 years by 48%. Reduced the running hours by 62%, which reduced fuel use by 62% over 4 years. And in the last year, in 2015, they actually managed to start reducing the number of generators as well by being cleverer about where the power zones are. But that's not the main, that will lead to additional savings in transport. But the main thing is reducing the overall capacity and runtime. And also Mysteryland Festival, also in the Netherlands, they reduced their capacity by about 40%, reducing their fuel use by the same sort of level. I think about 30% fuel use. And this has been broken down by audience day, by visitor day, so you can compare directly between festivals of different sizes. If the festival that we're working on grows, obviously the fuel use may grow also, but if it's compared to the number of people who are coming, the amount of fuel used is still going down. So the next steps after achieving those things is, as I started to talk about just then, is then looking at the end users of the power and trying to find more energy efficient ways of doing things using more energy efficient equipment, and then you can bring the power down even further and have smart power plan version 2.0. Yeah, that's that pretty much covers it really. So I don't want to go into too much technical detail, standing up here, but if anyone wants to talk to me about the principles behind it, I'm around all day. I'm around this evening at the ILMC drinks as well, so feel free to come and talk to me about it. Thank you.
So hi, I'm Sarah Cheyens and I work for Wheel of Green Festival. I'm in charge of the scenography of the festival, so I'm gonna explain you quickly the festival and then go on focus on the workshop and how do we work on the scenography. So Wheel of Green is a festival in Paris, a music festival. I don't know if you guys ever heard about it, but nice festival, which takes place this year, 4th and 5th June, in Bois de Vincennes. We're changing place because we're getting bigger. We thought about this festival in a sustainable way, as in every solution that we work on the festival. So just to give you the increase of the festival, we're a little festival, very small festival at the beginning with small solutions, but trying to like do a green festival. And we're getting bigger and bigger every year. So this year we're like more than 50,000 people for 2 days, which is kind of bigger for us because we were like 30,000 people at the beginning. We're gonna have 4 stages. We're getting bigger. This is why we are a green festival. So there is a lot of little stuff that we do, but the main idea is that we preserve the welcoming site. We reduce the CO2 emission. We have transport optimization. We have solar energy with creation of our own solar generator. We resource new eco-friendly productions. We have sustainable stage design, which is very important because 100% of the main stage the light of the main stage is generated by solar panel. We have all this treatment about trash and treatment, water optimization, and local food. And organic food. We have lots of little things that we do that make this festival like green in Key's way that we're think the festival as a laboratories of little action that we put in the festival to make it green. So some pictures so you see the mood and the look and feel of the festival. We have a think tank area place that we have conference. Last year we had 22 conference about sustainable solution experience. Here we can see Paul Watson was talking, and we had Rifkin also talking, economist. We have like several people, and it was very interesting because it was the first year that we were doing it this way, and people were very interested about having in a music festival talks like that, and it was very interesting for them to put it there. So yeah, this is Firefly solar system. So the main stage, as I told you, all the lighting was powered by this solar system, which was very good for us for the stage, because it was the first time that we were able actually to do the 100% of the lighting of the first stage energized by the solar panel. This is the second stage, so we're in a nice place. We're changing this place this year, but we can see like the look and feel of the festival. Here we have the food. We had 24 restoration on the festival with organic food, and we actually do an open call also for restaurator. So we choose the best organic restaurator, and restore today. We can put on the festival. That was with the rain, but still cool. Some pitch. Okay, so this is the focus of today. It's the workshop, and it's where I'm working on like all year long. It's at the beginning of the festival, when we were thinking, let's do a green festival to think it in a lab way. I was like, okay, we should think the scenography of the festival using wasted material and doing something nice with it to build the scenography. That's the way we have to think the scenography of a festival. If our festival is called We Love Green Festival, we have to do it this way. So this idea came, and every year we're trying to make it better and make it bigger. So now how does it work? We make an open call in our website, Facebook, and everywhere to make artists, designer, young creator participate and submit to We Love Green projects to develop their own project on the festival. They can actually imagine like pavilions, structure, furniture, signage, any kind of stuff that will help us building the festival, and we'll put the scenography of this festival on. We actually receive 200 projects every year. Last year was the first year of this project, so we receive 200 projects. In the same time, we go to school and we teach young designers and architects also how to build and imagine project eco-concepted. So we have 200 projects and also 100 projects coming from schools. This year we put up and we set a jury, which is this year Arne Cairns, Stéphane Rosenboom, Alexis Trécoire. I don't know if you guys know those people, but they're in France kind of famous. They're architect, designers, artists, media, and yeah. So we have, and also artistic graphic designer. We try to put in common this pool, and during like one day we're all gonna stay together, see all the projects that we have received, and choose the 20 best projects that we're gonna do on our festival. They have one constraint also when they respond to the open call, is to take the project in a sustainable way, as they have to use the raw material that they have to use. It's with waste material, recycled material to present the project. So yeah, I wanted to tell you also the benefits of working with young designers and young architects like that is really that for once they can create stuff scale 1, which is not really common when you're studying. They can develop a project from the idea to the conception, which is really important. They're meeting like artists and industry from professional, so that's really important also. And it's really thinking about experimentation of material and experimentation, or what kind of furniture do we need for a festival, how the impact of building furniture that will stay for 5 days in a festival, that should be like strong and not like just fell down at the first day. The raw material is where do we find all the materials? As we have choose the 20 projects that we're gonna do this year, we actually see the project, see the artists that are behind the project, and we Love Green have 4 people finding all year long all this material with partnership that we're working. For example, other festivals or other parades, venues, showroom that we're working with, and we take all their material that normally go to trash, and we just take it and put it in the site to build all the scenography of the festival. Then when we got the material, we got the artists, we got the project, we go for 3 weeks, 2 weeks, depends, on a dedicated place where we put all these people together with volunteers, artists, material, and that's where they actually build their projects with our team to supervise all that. And then we put all this stuff that we have created on the festival to use it and to build the scenography. A life cycle is more so here, this is what we build, we'll see the young designer working, and then some picture of the project that we have built on the festival. What is important is that we use actually trash or recycled material and we create something with it, and after that it goes to another place, which is other festivals or other partners that will take our furniture or take our stage design or take our signage, and that we'll use it. This is the main idea about the workshop, is that with nothing actually we create stuff and we make this festival nice with those stuff, and then it goes to other places and have a non-stop cycle life with that. So that's the main idea about how we're building the scenography of the festival. Thank you. If you have any question about how we're on the festival, the scenography, or...
Hello, yes, I'm John Winfield. I work at the University of the West of England in Bristol, and more specifically in the Bristol Bioenergy Centre. And we work with a technology called microbial fuel cells. And microbial fuel cells, we use bacteria to make electricity. So I'm going to kind of go over my talk and then talk to you about how these things work and how we've managed to progress the technology to move it out of the laboratory into real-life scenarios, for example, festivals. And I'll also maybe make you rethink about your urine, your bladders, and perhaps your bladders actually are fuel tanks for a very useful fuel. So first of all, what are microbial fuel cells? And this shows some of the kind of old-school cubic fuel cells that have been used for a couple of decades. They're quite small. They contain about 25 millilitres of liquid, and they've often been termed as biobatteries, and battery isn't really a correct term for these things, because a battery starts life with a set amount of reactants, and when those reactants are used up, the battery's dead, you can't use it anymore. With a fuel cell, as long as you keep feeding it fuel, it will keep producing power. And with a microbial fuel cell, that fuel can be wastewater, dirty wastewater, and that's a resource that's not going to run out. So how do these things work? Well, they are just like a battery. We have two electrodes, a positive and a negative electrode. The positive electrode sits outside in air, and it's separated from the negative by a porous membrane. And the negative electrode, this is where the bacteria live. And it's in a chamber, it's filled with liquid, and this is kind of free of oxygen. And it takes a kind of special kind of bacteria to be able to produce electricity, but they're actually found everywhere. So you found in aquatic sediments, in soils. I did a project with a school recently, and the children dug up the playground, just got some mud samples, and there's the right kind of bacteria just in their playground to produce electricity. And in our place, we use sludge from the wastewater treatment plant, and we feed this in, and the bacteria will grow on the electrode surface. And when we've got the right kind of bacteria, we can feed in the fuel. And let's say this is a dirty liquid full of nasty organic pollutants, stuff that we don't want, but the bacteria love. So they feed on this organic matter, and they get from this feeding, they get their own energy, they can grow, metabolize, do what they want, but they have waste products, just like we all have waste products as well. And these waste products are electrons and protons. So a lot of organisms, and most organisms, produce oxygen as part of their metabolism, but there are some organisms that, when there's not oxygen around, can use something else. And these bacteria, luckily for us, can use a conductive surface, and that's our electrode. So as they feed, they produce these waste electrons and protons, and they dump their electrons onto the surface of our electrode. And by connecting this up with a wire or a circuit to our positive electrode, we have a flow of electrons. Therefore, we have electricity. And an important part of the process is these waste protons that the bacteria produce, they pass through this membrane and they rejoin with the electrons and oxygen, and that kind of closes the reaction. But if you kind of think about what the bacteria are doing, they are consuming organic pollutants. They're actually removing it from the liquid. And the more they consume, the cleaner the liquid becomes. And the more they consume, the more electrons they produce. And so essentially what we have is the production of electricity at the very same time as we're cleaning this waste. So it's a twofold, one winner in two ways. It's fantastic. So how good are these things? What can they do? And then for a long time, these have been considered, they're still considered as low power systems. The bacteria are very small. We're kind of limited by how quickly their metabolism can go. But there's been some really nice examples of how we can still use the bacteria produce power for a useful purpose. And this is using energy harvesting. Energy harvesting basically means that as the bacteria produce energy, it's stored in capacitors, and when these capacitors are full, when there's enough energy there, it disperses into whichever device we're using. So in this case, this is a robot called EcoBot. And when there's enough energy in these capacitors, it would disperse into the robot and it could do a job. It would either move towards food or sense the environment or send signals backwards and forwards. It would then go to sleep, and then when there's enough energy again, it would do this purpose. More recently, we've been able to charge mobile phones using the power produced by bacteria. So in 2012, we were working with the kind of more old school small screen phones, but we kind of started moving on to more the smart screen. Just a few months ago, we kind of fully charged a smart screen phone, and it took about 40 hours, but we're cutting this down. But it's getting faster and more efficient all the time. But a lot of people in the field and outside the field, they're kind of saying that this is just a curiosity in the laboratory, that the power's low. We've got these great examples, but will we ever see it outside of the laboratory in everyday real life? Well, there's been a couple of kind of quite big developments just in the last couple of years that have helped us kind of push this to more exciting times. And this shows, I showed this before, this is kind of the old school material and style of the fuel cells, and it's taken from chemical fuel cells, which operated in very different conditions, and the materials they weren't designed for the environment the bacteria are like. And so we've always been restricted by these materials. So we've found that just using things like ceramic, and ceramic has been the big one. You can use ceramic cylinders. It provides an environment the bacteria love, so we get more power out of it. But also, it's much cheaper. So the thing I showed you before would cost tens of pounds to build one of those fuel cells. These you can build them for less than £1 a fuel cell. The other big development is the fuel urine. It's a fantastic fuel. It doesn't need to be treated, so it can come out warm and bubbly from the body, and the bacteria love it. It's very, very conductive as well, and it's just I can't tell you how impressive it is compared to the synthetic stuff we've been using for years. So putting these kind of two things together, we've actually now been able to move the technology out of the laboratory. So this is the first ever P-powered urinal. It was operated and still is being operated in the university outside the Student Union building. It had lots of boxes of microwave fuel cells underneath the urinal, and just two urinals in there, but the bacteria were continually powering a motion sensor. So whenever someone went into the toilet, it would turn on the lighting system, which was also powered by the bacteria. It was funded by Oxfam, and the idea is that these could be used in refugee camps, if successful. So this has been going on for a year, just powered by student urine, and it's doing really well, really stable performance. And this kind of sparked the next urinal, which we operated at the Glastonbury Festival last year. It was a bigger urinal. There was 3 troughs, which meant you could have 9 people peeing rather than just the 2. More fuel cells, and the idea behind this is that the lights would be turned on and just run permanently all through the night on the energy produced by the bacteria. And it worked really well. We also had a stand next to it, so we had people telling passers-by about what was working. We could show them the fuel cells, and it had a lot of interest. We managed to do a bit of science as well, so we could take out the urine at the end of it. I'm glad I didn't have to do that because it can smell a bit. But we could see that, yes, this urine or this liquid was getting cleaner as it went down the system. We also kind of accidentally built in a nice kind of rack for the cans of beer, which people used. We also found that people were pouring beer down into the urinals, and seeing the status of some of the people, I think the chemical content of some of the urine that was going in there was quite unique. But the bacteria, we had this stable performance over the whole period. They didn't flinch, they just carried on producing power, so they're very, very robust. And it was very popular. We kind of estimated that we had up to 1,000 users a day over the festival period, so it was a really successful trial. So just so that's the team. We're kind of what we're doing at the moment. There's lots of outreach projects with schools. We're actually building some similar urinals to be trialled in 2 developing countries with the help of Oxfam and the Bill and Melinda Gates Foundation, and that's hopefully at least one of them is going to be going out in a couple of months' time. We're looking at working at Glastonbury again this year. We're in discussions at the moment about maybe more than just the one urinal, and we're continuing to do lots more research, trying to make these things more powerful, more efficient. So just as an example, when I started 8 years ago, we were measuring output in microwatts. We're now measuring in milliwatts, which is 1,000 times different. So things are really moving really fast. And I personally think that we will see microwave fuel cells in everyday life, hopefully soon. So, thank you.
Okay, we're going to go on to the last presentation now, which I'll be giving alongside Teresa. Can I give that to you, please? Thank you. It's going to be very brief, partly because we're running late, but also after that presentation I need a wee. So sit down for this one. So I'm just going to really, actually, first of all, has anybody here applied for the Greener Festival Award in the past? Yeah, loads of people. And has anybody here assessed a festival on behalf of the Greener Festival? Great, quite a few people. Excellent. So I'm just going to really quickly go through the new elements of the relaunch of the awards, and then we'll touch quickly on training just before going for a coffee break. So for those of you who aren't familiar with the awards, it began in 2007. And a Greener Festival, it's set up really in the beginning to raise awareness around environmental issues and festival organisations. 10 years ago, there wasn't necessarily a huge amount of activity, certainly in the mainstream events, and so we were trying to raise the bar. There's 6 directors, 3 awards coordinators in different countries. We've got a team of volunteer assessors, many of whom are here. And then we also have senior environmental auditors, which we'll talk about a bit more shortly. Over the last, it's been 8 or 9 years that we've been running the awards, we've assessed over 300 festivals across 5 different continents. So we have our environmental coordinators and the assessors are based in the different regions. And this happened kind of by accident. We just set up a website based on some research we did, and then festivals around the world kept on contacting us, wanting to know more. And so it grew from that interest over time. We have 4 different categories for the awards, and this is based on, there's a self-assessment and an on-site assessment that happens for festivals, and these grades are based on the score that you get. So it may be that you're outstanding in the area of power, but perhaps haven't done so much with water or waste, or you may be fantastic across all areas. Through our scoring, you will be categorised into one of these areas. And with the developments, there's more feedback in the future so that you can get yourself to the next level if you're not already there. You can't really see this, but this was examples of some of the festivals that applied in 2014, which was the last time we ran the awards. Some of the outstanding festivals there, including Falls Music and Arts Festival in Australia, we've got Lightning in a Bottle in the USA, Shambhala in the UK, Boom Festival, Portugal. So there's quite a variety. We Love Green in the house as well. Quite a variety of festivals who apply. And so we took a year out last year because when we initially began, it was to raise awareness and raise the profile and try and encourage people to do more. But as you can see from just looking around the room and hearing some of the things that are happening now, people are very much aware, and there's a huge amount of work being done, and there's a lot of knowledge, and it's really quite advanced in the festival industry, which is really fantastic. And so we thought, okay, is the work here done, or should we continue, or let's just take a step back and reassess how we're processing the awards as well. Just thought I'd throw David Bowie in there for good measure. Actually, on some of the slides, I know we've not got much time, but if you can tell me what the band is for some of the logos, there is a tenuous link across these slides. So when we took a year out, we had feedback from the festivals, from the assessors, and from people who've worked with us over the years. As you're aware, we came to the conclusion that we'll continue with the awards, and that's because we found that festivals felt that the actual application procedure, whether they applied in the end or not, meant that they had extra guidance in order to know what to do, or what they might have missed on the event. And it also helped them to focus their efforts on site, because they knew that somebody was coming to have a look and assess them, and they were going to have to explain themselves once they arrived. There was an increased connection and engagement between events and then some of the sustainability practitioners who go out to do the assessments in the fields. And it also helped to raise the profile of the events that were doing a lot of work, good work. We also found that actually it's a huge amount of information, best practice that gets pulled as a result of going out there and gathering that information, and people are very willing to share it as well. So we've decided to continue. But we're making a few changes, and one is the self-assessment and the assessment criteria. The intention is for it to create a framework for an environmental impact assessment of an event, so that not only are you applying for an award, but you also have a working document that you can use to gauge your progress, where you're at, what you might need to do next. So that's the intention, is that it's a continuous working document. But we're launching the assessor training, which Teresa will talk about in a moment. Developing online resources, and we'll also give festivals a report, a basic report after each award is given. In the past, we would just tell you, okay, you've received this award, and that's it. Whereas now there's a much more of a two-way exchange, so that you can build on what you've done. And we're also trying to create a stronger network between the suppliers, between the different great ideas that are out there, and the festival organisers who are trying to make a difference. So we're doing that through associate membership of a Greener Festival, which you can find out more about if you speak to me after, particularly for service providers or practitioners in the industry. We've continued to have our local organisation connections around the world. Thank you. And
what's the Sounds for Nature?
Sounds for Nature. Oh, they're trouble. They're trouble. Sounds for Nature are our best friends in Germany. So the awards entry requirements. Yeah, if you're a German festival, by the way, you should speak to Holger, the man with the nose.
We can speak in German.
Show off.
Yeah.
And so the awards entry requirements, we now ask that every applicant submits their sustainability policy prior to applying. And this is partly just to make sure that before somebody applies for the award, they've already engaged their whole organisation and thought about, okay, what is it that is important to us and what are we trying to do? And that's from the top, from the directors, and then all the way through their organisation. So that's why we ask for the sustainability policy, because that should reflect that it has been thought about and it is ingrained. So the environmental impact assessment is embedded in the self-assessment. The assessment fees vary depending on which region you're in. So it's from £350 in the UK to $500 US if you're in the US. There's supporting evidence that needs to be provided, so we would generally not release the awards until around 3 months after the season, and that's because most of the information is going to be coming post-event. And the on-site assessors, they need to have access to the production areas. Obviously, they need to have interviews with the site manager potentially on site, so you need to be prepared that it is quite an engaging procedure. And so this is a bit about what's within the assessment. So we're looking at the local impacts, and that's more what's happening just around the festival itself. I'm not going to go into too much detail because I know we haven't got very much time. But then we look at the more global issues such as transport, power, waste management, water use, sewage, and then supporting documentation and the organisation itself, so who are the responsible people, etc. And then the external reach, so are you doing something beyond the walls of your own event? So I'm just going to pass over to Teresa now to introduce the environmental auditor training.
Yeah, thanks Claire. As part of the sort of re-evaluation and reassessment of what the Greener Festival is doing, and the fact that the assessment itself, we've changed the emphasis a bit, so there is an environmental impact study out of it. We felt we really needed to review the training that we were giving to our auditors as well. So we've extended that training, and we're offering one-day training for our auditors, and basically we are trying to cover overall 4 things. We want to train our auditors in our assessment procedures, the reporting format that we've created. We want our assessors to really understand the supporting documentation that we require for the award, and also we will cover, particularly for those perhaps newer to it, the sort of basic concepts of event sustainability and how all of that works. All assessors, so whether they're new, but hopefully we'll have some of our original ones coming back, all assessors are required to have event sustainability and or festival production experience before applying. And we have, in the past, and we continue to do, create our local network of assessors for each region, whether it's in the UK or beyond. We have, at the moment, 2 assessor days that we've got fixed in the calendar. The first one is actually in Manchester, and that's on the 29th of April at Manchester Met Uni. And the second one, for those of you who can't get to Manchester, is in London on the 6th of May, and UK Music, who are a music industry lobbying body, have kindly lent us a room to hold that, and that's in Whitehall, so just down Whitehall. And on the other side, there's just a list for those of you who can see it of some of the things that we're going to cover. So we'll look at environmental systems, legal frameworks, local impacts, procurement, transport, all of those sort of operational issues, as well as things like assessor code of conduct, the familiarisation of the forms that we use, and then the post-event reporting. That just very quickly sums it up. Back to you.
So in addition, we also, if you require it, have the opportunity for you to employ the services of our environmental auditors, our senior environmental auditors. And these are people who we've worked with over the years who've got a real wealth of experience. So if you're looking for in-depth environmental impact assessments, biodiversity impact assessments of your sites, noise consultancy, things like this, then we have people who are able to help. And I just want to thank Rob Scully as well, because he's given us a lot of help this year on redeveloping, particularly in relation to energy, our assessments. Thank you, Rob. That's my little artistic impression of Rob. So the associate membership I already mentioned. You can ask me about that later. What actually is this? I thought I had one of my fancy slide transitions. Oh yeah, I do. That's just contact details, but I just wanted to do that. Okay, we can have a coffee break now. So just next door, there's teas and coffees, and then we'll be back here in around about 10-15 minutes, if that's okay. Ready for the next session. Thank you.